See, for today's practical, we are going to see the thermal analysis. Okay, how we are going to perform the thermal analysis on the ANSYS, right? So all of you first see this problem. All of you see this problem. Okay, we have already solved this problem in the lecture, right? Analytically, we have already solved this problem in a lecture analytically, right? Clear? So what is this problem? A composite wall consists of three materials, right? So these are the three materials.
सर
Okay,
आपका
see
स्क्रीन नहीं
K1,
दिख रहा
K.
है।
Yes,
Okay,
sir.
okay, just yeah. Hmm. See this problem. All of you
Yes,
see
sir.
this problem. Okay, so see this. A composite wall consists of three materials as shown in figure. Okay, the outer temperature TO is 20 degrees Celsius. The convection heat transfer take place on the inner surface of the wall with T infinity is equal to 800 degrees Celsius and H is equal to 30 watt per meter square degree Celsius. Determine the temperature distribution in the wall. Okay, we are supposed to take this value of K1, this is the value of K2, and this is the value of K3, right? Okay, so see this diagram, what is given, right? So what we have these three materials, K1, K2, K3, right? So these are the three materials which are given. Okay, now see, on see, this is the inner side, this is the inner side, right? Where the temperature is T infinity. And what is the temperature? 80 degrees Celsius. And also on the inner side, you have heat transfer coefficient, that is H infinity, and its value is 30 watt per meter square degree Celsius, right? On the outer side, you have temperature, that is TO, okay, which is 20 degrees Celsius. The temperature on the outer side is 20 degrees Celsius, right? And you have this composite wall, which is basically made up of three materials. Okay, so as their conductivities are different, obviously these are the different materials. So their value are K1, K2, and K3. And what are those value? K1 is 25, K2 is 30, and K3 is 70. Okay, so this is a problem which is given. Simple, a composite wall which is made up of three materials with the values of conductivity as K1, K2, K3. On the inner side, it is exposed to an environment where the temperature is 800 degrees Celsius and heat transfer coefficient is 30 watt per meter square degree Celsius. On the outer side, it is exposed to a temperature of 20 degrees Celsius, right? And they're asking to determine the temperature distribution in the wall. Okay, what will be the temperature at this interface? What is the temperature at the interface of K1 and K2? What is the temperature at the interface of K2 and K3? So these temperature they're asking, right? All of you understood this problem?
Yes, sir.
Okay, now see, we need to solve. See, we have already solved this problem in a or in the lecture, that is in analytical method. Okay, so if you can see, okay, so this is the way how which we have solved this problem. Okay, and we have got these values of T2, T3, and T4. These values we have got. Similarly, we have determined the heat flow. You can see this heat flow here also we have determined. Understood? Clear? This heat flow also we have determined, right? So now we need to practice the same problem by using ANSYS, right? So if you need to solve this problem in FEA, your very basic step in FEA is the discretization, right? Is the discretization. Discretization, it is basically dividing the entire domain into number of subdomains, right? And there are certain criteria for discretization. Okay, first is change in material, then change in cross section. Okay, so these are the different criteria, right? So see, if you can see here, these are the three different materials. Okay, so I'm going to assign the three elements for these three different materials, right? And those elements are element number 2, element number 3, and element number 4, which I have assigned. Okay, because these are the three different materials. So for these three different material, these are the element number 2, element number 3, and element number 4, right? Now if you can see, okay, on this inner surface there is convection. On the inner surface there is convection, right? So for convection also I need to assign one of the element, and that element I will call it as element number 1. Listen, element number 1, it will be for convection. Okay, now if you see the heat flow from element rather from material number 1 to material number 2, that is from this this material, okay, to this material, it is due to conduction. Again from this material to this material, it is again due to conduction. Okay, but how the heat it is transferred, okay, from this, that is from inner surface, from inner surface to the wall of the this material K1. Okay, how it is transferred, it is by convection, it is by convection, right? Getting or not? So this element number 1, it is for convection. Element number 2, 3 and 4, these are for conduction, right? Now see, all of you see, if you see this convection element, for convection you doesn't require thickness. Okay, so here you can see there is no thickness required. Convection is going to occur. Okay, how the convection is occurring? For convection you require surface area, for while for conduction you require cross sectional area, right? Clear or not? All of you, are you able to get this thing or not? Let me
Yes,
know.
sir. Getting.
Okay, because see, because this background it has been already explained to you in the lecture, right? Okay, now see, from no, see, once you assign the elements, after that you need to assign the nodes, right? So this is node 1, node 2, node 3, node 4, node 5, right? Now see, heat will be transferred from node 1 to node 2 by convection, from node 2 to node 3 by conduction, from node 3 to node 4 again by conduction, and from node 4 to node 5 again by conduction. Is it okay? Is it okay with this one?
Yes, sir.
Okay, so see, you have element number 1, you have element number 1 for convection, and rest of the element are for conduction. Rest of the elements are for conduction. Is it okay? Is it okay or not?
Okay, sir.
Okay, at the same time in the problem they have mentioned the thickness of the every material. For element number 1 or for material number 1 it is 0.3, for material number 2 it is 0.2, for material number 3 it is 0.15, right? I'm talking about material. Okay, material number 1 it means element number 2, material number 2 it means element number 3, and material number 3 it means element number 4. Okay, now let's start this problem, okay, by using ANSYS. Is it okay? See, this is the problem which you already solved. Okay, so all of you know how to form the elements, how to number the nodes, right? This has been already known to you. Okay, but if this problem is not been solved analytically, at least if you want to solve the problem in ANSYS, you should form the elements and you should number the nodes, right? So this is enough. Okay, you form the elements and then you number the nodes, then it is enough to solve the problem by using ANSYS, right? So let's start. Okay, we used to go for this mechanical APDL product launcher 16.2, right? This we always used to go, right? So see, once you click on this ANSYS mechanical APDL product launcher 16.2, right? You'll come across this window. Okay, now see, this is already always remains same. Stimulation environment, then what type of license we have. Okay, now see this working directory, you browse the folder where you want to save the work. Okay, I'll go here. Okay, I'll select this folder, it is our practical number 3. Okay, and our name of the practical is, okay, thermal analysis. Okay, thermal analysis. Is it okay? Is it okay or not? So when you just bring this window vertically up, when you bring this window vertically up, okay, you can see the option of run there, right? Are you able to see the option of run? Here, can you see the option of run here? All of you,
Yes,
can you see
sir.
this? Just click on run. Okay, just click on run. Okay. Now just you need to just maximize this window. Just maximize this window, right? Now what we usually used to do, we used to make this background initially white, right? So go to plot control, right? Style, then go to color, okay? Then go to reverse video, right? So this background becomes white, right? Now see, in between, okay, you keep on clicking this save db, okay? In between, you just click on this. So whatever the work that you're doing, it will be get saved, right? Now see, all of you, we have performed already 2 experiment. So this is the time that you should tell me how to solve this practical, rather how to solve this problem. Tell me, all of you. All of you tell me how we should start.
Preferences.
See, all of you, let me know how to start it.
Reference, sir.
All of you, let me know. Right, preferences, whether all are there or not. Right, we need to go for preferences, right? Tell me which field we need to select.
Thermal.
Right. We need to go for thermal, right? I will click on thermal, right? I will say okay. Is it okay?
Yes, sir.
See, because we are interested to calculate the temperature distribution and heat flow, right? So for that, we need to go for thermal field only, right? Next, we will go for pre-processes. See, this is a very important state. Okay, where you need to define the elements type, right? So we will go to element type, right? We need to add the element. Okay, now all of you clearly see here. See, if you see this element number 1, it will be for convection. Okay, while if you see all other elements, that is element number 2, 3, and 4, it is for conduction. Okay, so we will select one element for convection. Okay, that we will use for element number 1, and we will again select one element for conduction that we will use for element number 2, 3, and 4. Let me know, is it clear or not? Otherwise, I will repeat again.
Yes, sir.
I will
Sir, repeat,
select
please.
one. Is there any doubt? You can ask. Not a problem.
Sir, repeat once more.
I'm repeating. See, I am going to select one element for convection, and that I will use for element number 1. Is it okay? One element for convection that I will use for element number 1.
Yes, sir.
Now I will select one element for conduction. I will select one element for conduction, and that element I will use it for element number 2, element number 3, and element number 4.
Yes, sir. Got it.
Is it okay?
Yes, sir.
Yes, sir.
Okay. Now come back to the screen. Now see, I will go here, add, edit, delete, because I need to add the element, right? I will go to add, right? Now see here, all of you, when we go to link, okay, can you see this element?
Yes, sir.
Conduction 33, convection 34, radiation, right? So these elements, right, like 34 and 33 are useful for us, right? Okay, so initially I have convection, so I will select convection 34, right? Understood or not? I will select initially convection 34 I will select. Okay, but see, I will click on apply. I will click on apply because I need to select again 3D conduction 33. Okay, it doesn't matter whether you click on okay or okay. Okay, but you need to again repeat this step. Okay, so what I will do, I will select link convection 34 and I will click on apply. So when I will click on apply, this type 1 link 34 is going to appear here, right? See, it is appearing here. Type 1 link 34. This is for convection element. This is convection element. Now I will select this 3D conduction 33. Okay. I selected that. Now I need to close it. So I will click on OK because I need to end this because I finished with my work now. Okay, I'll click on OK. Is it okay? Yes or no?
Yes, sir.
See, this link 34, it is basically the convection element which we will use for element number 1. And this link 33, it's a conduction element which we'll use for element number 2, 3, and 4. 2, 3, and 4. Understood or not?
Understood, sir.
Sir.
Okay. So see, now we are finished with this, right? So I'll click on close, right? Now see, when you finish with any option, you try to minimize it because inside option you will get many options, right? So you need to minimize those options. Now see, what is the next step? We need to go for real constant. Okay, but see here, if you can see this, okay, real constant, it is nothing but area. Okay, so if you go for convection, you need required surface area, and if you go for conduction, we required cross sectional area, right? So if you can see in this problem, okay, see, this is a thickness, right? This is a thickness which has been given, right? And your area is a cross section area, right? That is area perpendicular to path of heat flow, right? Getting or not? So here length is not given, breadth is not given, right? Okay, so in such cases, okay, what we have done here is, see, we have assumed area as 1 meter square. All of you can see in this problem what we have done, we have assumed area as 1 meter square, whether it is cross section area or whether it is surface area, we have assumed it as a 1 meter square. Okay, so when you assume the area as 1 meter square, you will get the heat flux. Okay, you will get a heat flux. Okay, that is basically watt per meter square, right? See, when you assume the area as 1 meter square, you will get the value of Q in watt per meter square, right? You will get the value of heat in watt per meter square. And when you have the heat in watt per meter square, it is called as heat flux. Getting or not? Getting or not? See here. What we have done, we have taken area here as 1. Similarly, for conduction also, we have taken area as 1. Okay, for convection also and for conduction also, we have taken area as 1 meter square. So whatever the values of heat we are getting, they are in watt per meter square. You can see in the problem, watt per meter square, and that is nothing but called as heat flux, right? Is it been understood to everyone?
Yes, sir.
Okay, so we'll go here, right? We'll go to real constant. Next, we will go to add, edit, delete, because we need to add the real constants, right? We need to add those areas, right? So see, I required one surface area for convection, okay, and again one surface area for conduction, right? So I'll go to add. I will go to add. See, whenever you are going to add the area, you need to go through the link. Okay, whenever you are going to add the area, you need to go through a link, right? So here I will be able to see 2 links. Okay, if I selected link 34, that is basically convection element. That is basically convection element. I need to add surface area because for convection you require surface area. So when I go to link 34, rather when I select link 34 and when I will say okay, it will ask me to enter the surface area. Getting or not? Getting or not? Let me know.
Getting, sir.
Sir.
Okay. So what value of surface area we should enter? 1 meter square. Okay. So this is basically real constant set number 1. This real constant set number 1, which we will use for element number 1. Okay. Where the surface area is required is 1 meter square. Understood or not? Let me know. See, this is real constant set number 1, which we will use for element number 1, because element number 1, it is convection, right? which requires surface area, and surface area we have taken as 1 meter square. See, this is 1 meter square. Understood? Is it clear or not?
Clear, sir.
See, now I need to click on, tell me which option I should click, okay or apply?
Apply.
Which option I
Apply.
should click, okay or apply?
Okay, sir.
See here, if I
Okay,
click on
sir.
apply, see here, all of you, if I click on apply, it will create second set of real constant. It will create what? Second set of real constant. Here, it will create second set of real constant, but with the same convection surface area. Okay, which we don't require, right? We now need to create for conduction. Getting or not? Now we are interested to create the area for conduction. Okay, so that's why I need to click on OK. Okay, see, if I click on here, apply na, again it will create the real constant set number 2. Okay, but for convection again. But why need to create for convection again? We already created for convection, right? So I need to click on OK. I'll click on OK. Understood or not? Yes or no?
Understood, sir.
Okay, so see here, this set 1 you have created, right? You have created set 1. You have created set 1. Okay, and that set 1 we will use it for, element number 1. This set 1 we will use it for element number 1, because in set 1 you have entered the surface area. In set number 1 you have entered the surface area. Understood? Now we will create one more set number 2, that is for conduction. Okay, so I will go to add. So when I need to create the second set for conduction, obviously I need to select this link, because this link it is for conduction. Okay, so I will select this link 33, then I will click on OK. Okay, so now you can see the difference what you are getting here. What it is asking, cross sectional area, because I have selected the link for conduction. Okay, and again, what is cross section area? We require that cross section area to be equal to 1. Is it okay? Is it okay
Yes.
or not? Let me know.
Yes, sir.
Okay, now tell me, what should I do next?
Apply.
Why?
Because there are two of other, sir.
Ah,
दो
see,
और भी
now, right. See, now question is, no need to create again 2 more sets. What we will do, we will use this same set, that is set number 2. Set number 2. Can you see the set number 2? Real constant set number 2. We will
sir.
use this same set for element number 2, 3, and 4. Is it okay?
Yes, sir. चलेगा.
Is it okay or not? We will use same set, that is real constant set number 2, for element number 2, 3, and 4. Is it okay?
Yes,
Yes.
sir.
Is it okay or not? Okay, so I'll just click on OK because I need to finish it. I will click on OK. Now see here, set number 1 for convection and set number 2 for conduction, right? Set number 1, see, what is the meaning of set number 1? Its surface area is 1. And what is the meaning of set number 2? Its cross-sectional area is 1. Okay, yes or no? So see here, for this element number 1, I will use set number 1 where I have entered surface area as 1. And for element number 2, 3, and 4, I will use set number 2 where I have entered cross-sectional area as 1. Is it okay?
Yes, sir.
Is it okay or not? See, I am telling you, there is no point in creating set number 3, set number 4, and like that, right? Because you consider the same value of area, na, that is 1. Understood? So that is not required, right? Now see, now all of you see here. Now we need to go to material properties, right? Material properties. Now see, if you see for element number 1, What is the material property for element number 1? Tell me. What is the material property for element number 1?
H.
H, right? See, all of you see here. For material number 1, element, see, for material, sorry, for element number 1, material property is H, heat transfer coefficient. But if you see element number 2, 3, and 4, for element number 2, 3, and 4, material property is thermal conductivity. Getting or not?
Getting, sir.
Are getting?
Yes, sir.
Okay. For element number 1, material property is heat transfer coefficient. But for element number 2, 3, and 4, material property is thermal conductivity. Okay. So that we supposed to enter. Okay. So all of you, can you remember this value? 25, 30, and 70. Okay. Just note down this value and let me know. See, for first value, heat transfer coefficient is how much? 30. Getting or not?
Yes, sir.
Okay, you are supposed to tell me this value, because see, when I will come out of the ANSYS window to see this value, then at that time it may possible that it will hang, because see, there you are not giving any input and you are coming out of the window. That's why I'm asking you to remember this value, right?
Okay, sir.
For first, okay, you remember this value. For first element, H is 30. For second element, conductivity is 25, 30, and 70. Is it okay?
Okay.
Yes, sir.
Okay, so now okay, now go to material properties, right? Now we need to go for material models, right? Material models. Now see, I'm selecting material number 1. See, material model number 1, and this is basically for convection. This is for convection. Material number 1. See, I'm telling you, for convection you doesn't require material, but you need to here assume it as a material. It is just a name of the material. Okay, this is just a name. This is just a name. Okay, so for this material model number 1, we will enter the value of heat transfer coefficient. We will enter the value of heat transfer coefficient. Okay, so we will go here for thermal, right? Thermal. Now can you see this convection or film coefficient? Can you see this one?
Yes, sir.
Convection or
Yes,
film
sir.
coefficient. So here you need to enter the value of heat transfer coefficient. So when I will just click, okay, just tell me the value of,
Okay, sir. 30.
okay, HF, how much it is? 30 watt per meter square degree Celsius. Is it okay with this one? All of you?
Yes, sir.
See, all of you, you let me know the exact this values correctly. Yeah. Otherwise, we will enter some different value, so we will get some different answer, and we will try to compare those answers, right? So it will never match. Okay. Is it okay with this one? H is
Yes, sir.
30. Right? So I have entered this. H is 30. I have entered. So I will click on OK. Right? I'll click on OK. Right? Now see, this we have finished for element number 1. For element number 1, where we need to enter heat transfer coefficient. This we have done. Right? Now we need to create 3 more materials. Right? 3 more materials. So for that, I need to go for new model, right? Material and new model. I will click. Okay, so my material number is 2. Material number is 2. Is it okay? That means this element number is 2, right? Element number is 2. Understood or not? This is element number 2. Define material ID, it is 2. It means it's a element number 2, right? Getting or not?
Yes, sir.
Okay, so I will click here OK. I'll click OK. Now see, for second element, we should enter the value of conductivity, right? For second element, we should enter the value of conductivity, right? So we should click on conductivity, right? And obviously the material is isotropic, right? So I should click on isotropic. Now see, for second material, what is the value of conductivity?
25.
25.
I'm talking about second element. That means you
Yes,
need to
sir.
put the value of K1.
25. K1 equal to
It is
25.
25. Understood? Yes or no?
Yes, sir.
Okay, so I will click OK here. Right? But I have 2 more material, right? So I need to go for material, new model, right? So this is element number 3. This is element number 3, right? Element number 3. So I'll click on OK, right? Now again, I will click on isotropic. See, element number 3, it means K2, value of K2. Understood, na?
30.
30, right? 30 value I'll enter. Now I will say OK, right? I have one more material. So for that, I need to go for material, new model, right? So this is my element number 4. Understood? Element number 4. Say OK. Now again, click on this isotropic. Tell me, see,
20.
element number 4 means K3. K3. Element number 4 means K3.
70, sir.
70.
70.
Okay. 70, right?
Yes,
So
sir.
I'll say okay. Okay. Now see, all of you. Here in convection heat transfer coefficient, what you have entered? Heat transfer coefficient you have entered, right? In material number 1, material number 2, what you entered? You entered K1, right? In material number 3, you entered K2, right? And in material number 4, you entered K3. Is it be understood?
Yes, sir.
Yes or no?
Yes,
Yes,
sir.
sir.
Okay, so I'll just close it. Now let me come back here. See here. For material, see here, element number 1. For element number 1, I have entered convection H. I have entered the value of H. For element number 2, I have entered K1. For element number 3, I have entered K2. And for element number 4, I have entered K3. Right? Okay, so can you see this one? So I'll just minimize the material props. Now see, there is no need to go for section because you have already defined the real constant, right? So we'll directly go to modeling, right? We'll go to modeling, right? See, in modeling, basically we are interested to initially create the nodes. And when we have created the nodes, we need to connect those nodes so as to create the elements in between. Okay. So initially we need to create the nodes. Once we have created the nodes, we need to connect the nodes. Okay. So we'll get elements, right? So I'll go to create. Okay, I'll go to nodes. Okay, when I then after that I need to go in active CS. Okay, but before just clicking on inactive CS, okay, because when I click on inactive CS, it will ask me to put the coordinates. Okay, just here when I click on inactive CS, it will ask me the coordinates. Okay, so before that I should know the what are the coordinates, right? So for that, let's come back to the diagram. Okay, now see, all of you see here. All of you just see here. See. Now I need to assign the coordinates to every node, right? I need to assign the coordinates to every node, right? Right? So what I will do here is, okay, see what I will do here is, see, while assigning the coordinates, see, what do you mean by assigning the coordinates? You need to measure the location of every node, right? We need to measure the location of every node, right? But if you need to measure the location of every node, with respect to what node you are measuring it, that you need to define first. Okay, right? So that means you need to assign one of the node as a reference node, right? Getting or not? Getting my point?
Yes,
See,
sir.
what I'm asking, you should assign the coordinates to every node, right? But if you need to assign the coordinate to every node, you need to assign one of the node as a reference node, because with respect to that node only you will assign the coordinates, right? Now here question is which node we will assume as a reference node, right? So as a practice or as a habit, what we used to do, we used to take the leftmost node as a reference node. Okay, so we will move on the right hand side, okay, in the positive direction. Getting or not? Getting this one? So what I will do, I will assume, are you able to get the thing what I'm telling?
Yes, sir.
Yes, sir. Continue.
Okay, so what I will do, I will assume the node 1 as a reference. Okay, so for node 1, I will assign the coordinates as 0, 0. Is it okay? Is it okay with this one, node 1?
Yes, sir.
Okay, so what I will do is, see, for node 1, I will assume its coordinate as 0, 0. All of you see here for node 1. Okay, so for node 1, we will assume it as 0, 0. Okay. Just a minute.
Sir, screen seems to be freezed or something else.
Yeah, it's not freeze. It's not freeze. I'm trying to annotate it. I'm trying to annotate it.
Okay, sir.
Okay. Just a minute. Just a minute. See, can you see this node 1 now? Can you see this node 1 now? Okay. Let me
Yes, sir.
close this one again. Okay. Just a minute. All of you
Yes,
can
sir.
see this one? Okay. Now see what we will do for node 1. For node 1, we will assign its coordinate as 0, 0, right? 0, 0. This is for node 1. Okay. This is for node 1. This is for node 1, right? Otherwise, okay. It's getting double. Okay, can you see this node 1, node 2, node 3, and node 4?
We
Yes, sir.
can see.
Okay, node 1, node 2, node 3, and node 4. Okay, so let me write down here only. I'll write down here. Okay, so can you see this node 1? I will write down for node 1. Okay, its coordinate are 0, 0. Is it okay? For
Yes,
node
sir.
1. Okay, here I will write down. So for node 1, it is 0, 0, right? Now see, tell me what is the location of node 2? See, because node 1 I am going to assume as a reference node. Okay, where coordinates are 0, 0. Can you tell me what is the coordinates for node 2?
0.3, 0.
Node 2, tell me for node 2, what are the coordinates?
सर x में 0.3, y में 0.
सर एनी डिस्टेंस पे ले सकते हैं ना नोट 2 को, मतलब 1 के रेफरेंस में, क्योंकि कोई डिस्टेंस तो दिया नहीं है उसमें.
See, if there is no distance between 1 and 2, obviously 1 and 2 will be at the same location. See, in between node 1 and node 2, what is happening? It is a convection. So for convection, you never have any thickness, na? Yes or no?
Yes, sir.
Getting this point or not?
यस सर.
See how the heat will be transferred from node 1 to node 2? It is only by convection. So for convection, obviously there is no thickness. The convection occurs due to the exposed surface area, right? Yes or no? So for node 2, it is again 0, 0. Getting or not? Now go to node 3. Now tell me for node 3.
0.3,
What is the
0.
coordinate of node 3 with respect to node 1?
0.3,
Right.
0.
0.3, 0. That is right. 0.3, 0. Is it okay?
Yes, sir.
Yes or no? Now
Yes.
tell me, what is the coordinate of node 4 with respect to node 1? Node 4 with respect to node 1.
0.5, 0.
Right. It is 0.5, 0. Is it okay? Yes or no?
Yes,
Yes,
sir.
sir.
Next, what is the coordinate of node 5 with respect to
0.65.
node 1,
0.65, comma 0.
right? 0.65, comma 0. Is it okay? Have you understood this?
Yes, sir.
Coordinates.
Yes, sir.
Understood, na? So now
Yes, sir.
we need to see with these coordinates, we need to form the nodes, right? So with these coordinates, we should form the nodes. Is it okay? Now
Yes,
what
sir.
we'll do, we'll have again return back to this one. We'll again return back to the screen. Okay. So all of you understood this one?
Yes, sir.
How to form the nodes and elements? Okay. So we'll keep it as it is. Right. Now we will go to our window, right? We'll go to our window, right? Now we can see this node 1, right? This you have it, right? So with this, we should form the nodes, right? So we'll go to inactive CS, right? We need to create the nodes in active CS for node number 1, right? What are our XY coordinates? 0, 0. Is it okay?
Yes, sir.
Yes or no? So we should click on apply, right? Because we need to create 4 more nodes, right? So I'll click on apply, right? Then we will go to node 2, right? What is the coordinate? Again, same
0, 0.
0, 0. So again, we'll click on apply. Now we will go to node 3. What is coordinate? 0 0.3, 0 0.3, comma 0. So I will click on apply again. I'll go to node 4. What is the coordinate?
0.5.
0.5, right? So I'll click on apply again. I'll go to node 5. Okay, where the coordinate is 0.65. Is it okay?
Yes.
Now I need to finish it, right? So I'll click on OK. Getting or not?
Yes,
Have you
sir.
got this? Got this or not?
Got it, sir.
Now see here. What is the next step? Tell me. We have finished with the nodes, right? Now what is the next step? See, I'm telling you. I'm what we can say. We are taking the experiment. Okay, I'm making you to understand. That is the reason why it is taking that much time, right? But if you know how to solve, it will hardly take 5 minutes to solve the problem. Getting or not? It is not more than that. 5 or max to max 10 minutes, right? So tell me, what is the next step?
Elements.
What is the next step? We need to go for elements, right? We need to go for elements. Okay, but as I told you before connecting the elements, you should set their properties. Okay, and where you're going to set these properties? In element attributes, right? So in the element attributes, we should set their properties. Is it okay?
Yes, sir.
Yes or no? Okay, so we'll set their properties in element attributes. Now just come back to the screen. Okay, can you see this one? Okay, now see, you want element number 1 between 1 and 2. Getting or not? See here, you want element number 1 between 1 and 2. Okay, so let's before connecting the elements, let's set their, what are the properties there. Okay, let's set their properties. Okay, so let me write down first here. Okay, element number. Okay, element number. Okay, we'll write down here element number. Okay, then it's element type. Element type, right? Then we should have just a minute. Just a minute. Okay. So let's write down here only, because I'm interested to make one table, right? I'm interested to make one table here. Just a minute. Now see here, we will write down here element number. Okay. Then we will write down here nodes. Okay. Then we will write down here element type. Element type. Right. Then we will write down here real constant set. Okay. See here, all of you see here. This is very important. Real constant set number. Real constant set number. Okay. Then we require material number. Material number. Okay. Material number. Okay. All of you see here. Can you see this one? All of you, can you see this one? Okay, see, this is very important before you connect these elements. Okay, so until and unless you know this, okay, you can't move ahead, right? Now see here, all of you. See, tell me element number one. Element number one. Let's talk about element number one. Tell me element number one. It is between which node? Tell me element number one. It is between which node?
1, 2, sir.
Can you tell me about this? Element number one. It is between which node?
1,
1 and 2.
1 and 2, sir.
Right? Element number one. It is between 1 and 2. Right? Element number one. It is between 1 and 2.
सर एक्सेल नहीं है.
Just a minute. Just a minute. See, that is not a problem of Excel, because see, because why I'm doing this one is that with the diagram only you should understand that, right? That is not a problem. I'll write down here.
ये इमेज को ओपन विथ पेंट कर दो.
No, not a problem. Element number here also you can see na element number, right? Element number with element number with element number with nodes. Then what you seen? Tell me what do you seen? Element type. Element type, right? Then we have seen what?
Real constant.
Real constant set number. Real constant set number, right? Then we have seen material number, right? Material number, right? Is it been okay with this one? Okay. Now go element to element wise. Element number one. for element number 1. Tell me, element number 1, it is between which node?
1 and 2, sir.
Tell me, it is between 1 and 2, right?
Yes.
It is element number 1. It is between 1 and 2, right?
One and
Element
two.
number 1, it is between 1 and 2. So I'll write down here. It is between 1 and 2. Element number 1, it is between 1 and 2. Okay, now it is element type. What is the element type? Whether it is conduction 33 or
34, sir.
that means it is convection or conduction. Tell me, convection or conduction? Element number 1,
34.
convection. That means it is 1, right? It means it is 1. Yes or no? It is 34, na? For convection,
Yes,
which you have
sir.
used? Yes or no?
34.
Yes, sir. Set one.
I will write down here convection 34, right? And real constant set number. What is the meaning of real constant set number? Okay. For convection, which set we have created? We have created which set?
One.
Tell me.
Set one.
Set number 1.
Sir.
Okay. Understood or not? See,
Yes,
this is
sir.
very important. Set 1. Okay. And what is your material?
1, sir. Material.
One.
number.
Material is 1, right? Your material is 1. So I will write down here. Your material is 1. I will write down here material is 1. Okay. Real material 1. Is it okay? Is it okay with this one? Can we move to next material element? Element number 2. Tell me element number 2. It is between which node?
2 and 3.
Tell me. It is
2 and 3,
between
sir.
2 and 3. Is it okay?
Yes.
Yes or no? Next. Tell me its element type.
Conduction 33.
It is
Conduction
conduction,
33.
right? It is conduction 33. Getting or
Set
not?
two
See, that's
material.
why I have not created many sets, right? Not required to create. Here, what is set
Set
number?
two, sir.
Here,
Set
set
two.
number is 2, right? And here, what is your material? It is material is again material is 2, right? Understood this one?
Yes, sir.
Now go to next. Real constant element number what? 3.
3.
Okay, it is between which node?
3
Tell
and
me, it
4.
is between 3 and 4, right? 3 and 4, right? Which element you will have?
Conduction.
Which element you will have? Right, it is conduction 33, na? Yes or
sir.
no?
Set
Which
2.
set you will have?
Set
Okay,
2.
it is obviously with the set 2, right? It is set 2. And which material you will
three.
have?
Material
Material
3, sir.
Right, you have material number 3. Right, you'll have material number 3. This material is 3. Next, element number 4, right? It is between which node?
4 and 5.
Tell me. It is between 4 and 5, right? Which element you will have?
Conduction
33.
3.
Right, conduction 33, right? Next, which set you have?
Set 2.
Right, you should have set 2. And which material you should have?
Material 4, sir.
4.
Right, you should have material 4. Understood, na? Have you understood this? That is the reason why I have made this table, right? Now, once you have it, right, you can start with this one. Okay, you can directly start with this one. Okay, so we'll go here now. Okay, now we need to create it, right? We are supposed to create those. Now tell me how I should create element number 1. I should create the element number 1 with these properties, right? So these properties I should initially set, right? So how I'm going to set these properties? Tell me how I'm going to set these properties. I need to go to element attributes, right? So I'm going to element attributes, right? See here, link it is what? 34, na? Is it okay?
Yes, sir.
Sir.
Your material number is 1. Is it okay?
Yes, sir.
And your real constant set number is 1 also. Real constant set number is 1 also. Is it okay?
Yes. Yes, sir.
Okay, so I'll say okay. There is no need to change. Now I'll go to auto numbered, right? Now I need to go to auto numbered, right? Because I need to connect those. Okay, now here coincidentally, what is happening is you need to create these two nodes, node number 1 and node number 2, which are at same location. Getting or not? See,
Yes.
node number 1 and 2 are going to lie at the intersection of x, y, z axis. That is at 0, comma 0, right? These two nodes are at same location. Okay, so I will go to auto numbered, right? Because I need to create those. I will go to through nodes. Okay, so this window will come, right? So it will ask me to basically pick those nodes, that is node number 1 and 2, in which I want that element number 1 to be connected, right? So what I will do, I will just click here. Okay, I will click here. You can see the arrow. I'll click here. So what it is saying, see, obviously there will be some message because there are two nodes, right? So see, there are two nodes at this location and picked node is 1. So is it okay? Initially we need to select node number 1 only. Is it okay with this one?
Yes.
Yes, sir.
So I'll say okay. I'll say okay. I say okay, right? Now again I'm going to click on the same point. Okay, that is at the intersection of x, y, z axis. I just clicked. Now see, again it is showing pick node is 2. Okay, but you already picked that node number 1, na? You already picked that node number 1. Okay, now here you need to click on next. So when you click on next, you can see this pick node is 2. Is it okay?
Yes.
Yes, sir.
Okay, so pick node is 2. Okay, that we want. So I will say okay, right? Now I have finished with this one. So I'll click on okay. I'll click on okay. Is it okay with this one? So element number
Yes.
1 is formed. Element number 1 is formed, right? Clear? Now we need to go for element number 2. We need to go for this element number 2. Okay, so with these properties. So initially we need to set the properties, right? So I'll go to element attributes, right? So all of you tell me the properties now.
Link 33.
What is that?
Link 33.
Tell me, this link should be 33. Material number 2,
Real
right?
set.
Real constant set number 2. See na? Link 33, material number 2 and real constant set number 2. Is it okay? Yes or no?
Yes, sir.
So I'll click on OK now, right? Again, same procedure. I'll click on through node. So this window will come. Now I need to select node number 2 and 3, right? See, for element number 2, I should select 2 and 3, right? So 2 will be here. 2 will be here. So I'll click here. So pick node is 1. Okay, that I don't want. So I'll go to next, right? Okay, so I'll say okay. Because now 2 is selected, so I should say okay. I said okay, right? Now I need to select node number 3, right? See, 2 is selected. Now I need to select node number 3. So I'll click on node number 3. I will say okay, right? So this element is connected. Understood? Yes or no? Right? Now I need to create element number 3 with these properties. 33 set to material 3. Okay, so I'll go to element attributes. Okay, link is 33. See, for element number 3, it is 33. Real constant set number is 2. See, real constant set number is 2. But material is 3, right? Material is 3. This I supposed to change. Yes or no?
Yes, sir.
Is it okay? So I'll say okay. Now I'll go to through nodes, right? This element number 3, it is between 3 and 4. So initially I will select 3, then I will select 4, then I will say okay. Is it okay? Now again, I need to create element number 4 with these properties. So I'll go to element attributes, right? I'll go to this, see link is 33 only. Then material number is 4. You can see is for 4, element number 4, material is 4. The real constant set number is 2 only. See, this is 2 only. And link is this conduction 33 only. Is it okay? Yes or no?
Yes, sir.
So I'll say okay, right? Now I need to go to through nodes. I should go to through nodes. Now this element number 4 I want between 4 and 5. So initially I will select 4. Then I will select 5. Say okay, right? So these are the elements formed. If you want to see whether you correctly form the nodes and elements or not, you can go to list, go to nodes. So you go to list, then go to nodes. Okay, so you can see this window. Okay, let me. Okay, just a minute. So you'll go to list, nodes. I will say okay. So see, node number 1 and 2 are at 0, 0. Node number 3 at 0.3. Node number 4 at 0.5. Node number 5 at 0.65. Right? So we have correctly formed the nodes. Right? Now we need to, if you need to see the elements, go to list, elements. Right? We'll go to attributes plus nodes plus attributes plus real constants. Right? Anyone you can select. See, element number 1 is material number 1, type 1, real constant set number 1, right? For element number 2, all are 2, right? And from element number 3 onwards, only material is changing, that is 3, 4. Getting or not?
Yes, sir.
Yes or no? Okay. So this is all about elements, right? Now we should go. Okay. Now see, we have assigned the, or rather we have formed the nodes. Okay, we have formed the elements. So now step will be, what is the next step? Tell me, what is the next step? Tell me, what is the next step you can see here? You just check what is we have entered and what is remaining. What we have entered and what is remaining. What is remaining? Tell me.
Temperature.
Temperature we have yet not applied, right? So for that, see, we need to go to loads. Okay, we need to go to this, define the loads. Okay, understood? Huh. Understood or not? Tell me.
Yes, sir.
Go to define the loads, then go to apply, right? We need to apply what? Thermal. Okay, we need to apply thermal and we need to apply temperature. Okay, but what is the temperature at node 1? At the extreme left hand side, what is the temperature? 800. And what is the temperature at node 5? It is 20. Okay, understood na? So we'll go to temperature on nodes. Okay, so I will select node 1. So I'll click on this node. So this pick node is 1, which I want. So I'll say okay. And again, I will say okay, right? So what I need to apply? I need to apply temperature. And at node 1, what is the temperature? 800. Getting or not? Let me know.
Yes, sir.
So I'll say okay. Understood? Now tell me, what is the next step? Again, I will go to on nodes. I'll select this node 5. And at node 5, what was the temperature? I'll say okay. Temperature is 20, na? How much? It is 20. Right? So again, I will say okay. Is it okay with this one? All of you?
Yes, sir.
Okay. Now tell me. Tell me what is the next step which we'll do? Tell me what is the next step that we'll do. Right now we need to solve this, na? Clear or not? We should solve it, right? So for that solution, okay, see the solution, you go to solution, you go to analysis type, okay, and here you can see the option of solution control. Solution control. Can you see this option, solution control?
Yes.
Right? Where you need to make this automatic time stepping on. Okay, this is very essential. Automatic time stepping on, right? And just say okay. Simple. Just say okay, right? Now we need to basically solve it, right? So you go to solve, right? Then go to current ls that we usually used to do, and they say okay, right? So you can see this warning executed, right? We should say yes. Okay, so you can see this option, solution is done. Okay, so just close it. Again, close this message, right? Clear? Now see, thing is like that, we should get the answers now. Okay, so for getting the answers, we need to go to general post proc. Is it okay with this one? Is it okay with this one?
Yes.
Okay, we'll go to general post proc, right? After that, we will go to plot the results. See here, we will go to plot the results. Initially, we should know the temperature distribution, right? So we'll go to counter plot, and temperature you will get it at the nodes, right? You will get it as a nodes. So we need to go for nodal solution, because at the nodes only we will get a temperature distribution. Okay, and temperature, it is nothing but a degree of freedom, right? Degree of freedom. So this we need to select nodal temperature. See, this is how I am getting the answers. Okay, nodal solution, DOF solution, and nodal temperature. So when I will say okay, you can see some temperature distribution like this, right? Can you see?
Yes.
Yes, sir.
3D,
It's
sir.
okay. This is your right. We want this to be in 3D. So go to plot control. See, before that, if you want, you can capture the image. Go to plot control and capture the image of this 1D diagram also, right? Just close it. If you want to see the 3D, go to plot control, style, right? Then you go to this size and shape. Okay, just make this on. Display of the element, you make it on. And say okay. So this is the diagram, 3D diagram you will get, right? You can see this isometric view. Says or no?
Yes,
You
sir.
can see the temperature distribution. See, in the blue region, you have maximum temperature distribution, right? And in the, see, blue, it is on the right hand side where you have
Minimum, sir.
maximum, sorry, minimum temperature distribution. And this red, it is on the left hand side where you have maximum temperature. Okay, so temperature will decrease from maximum towards minimum. Getting or not? See, this is the minimum value and this is the maximum value. Getting or not? So it will decrease from maximum to minimum. That is from red to blue. Okay, in this manner it will decrease. Getting or not? All of you getting this diagram?
Yes, sir.
All of you getting this diagram or not? Right? Now we'll just minimize it. Right? Now see, we need to
Sure.
see what is the temperature, right? We should get the temperature at every node. Okay, so see that. For that, you go to list result. See, whatever the thing that you have done it for a plot, same you need to do it for list. Okay, you'll also see this list the result. Okay, and I need the temperature, and temperature I will get it at the nodes. So I should go to nodal solution. right? And temperature, it is nothing but degree of freedom where I should get the temperatures, right? So nodal temperature, I'll write down. See, similar options you have seen in the plot results. Similar option you will get it in a nodal solution, right? You can see this one, nodal temperature. So I'll click on OK. So these are the values that you got. These values you got. Understood? Yes or no?
Yeah.
You can see this temperature at 2.
Yes,
What is the
sir.
temperature at 2? 9.79. Let me check with which we have got, right? Temperature at 2. Can you see this value? 319.8. 319.8, right? Yes or no?
Yes, sir.
See, what we are getting? 319.79. So it is approximately same. Go to T3. It is 146.91. T3, 146.91. We are getting same value, right? Yes or no?
Yes,
Go
sir.
to T4, 50.87. Just here, 50.87. Same value we are getting. Understood? Yes or no?
Yes, sir.
Yes, sir.
So you just go to file and save this file wherever you want, right? Just go to file and save this file because these are your answers, right? So you should save this value. So I'll just close it. See, all of you, we have calculated the temperature. Now we should get what? Heat flow we should get, heat flow, right? Yes or no? Temperatures we have calculated, we should get heat flow, right? And heat flow, it is nothing but a sort of reaction. See, all of you, stiffness into displacement is equal to force, and force, it is nothing but a reaction. Similarly, stiffness into temperature is equal to heat. So obviously heat will be a reaction. Okay. So for getting the value of heat, you need to go to reaction solution, right? So reaction solution, that is nothing but heat flow. We should get heat flow. So I'll click on OK. I'll click on OK. So can you see this value? What is the heat at node 1? Heat flow at node 1, 14406. That is Q1. Na? Q1 is 14406. Understood? Na? Yes or no?
sir.
Yes, sir.
Q1 is 14406. Just check this value. Q1 14406. Is it okay?
Yes, sir.
Yes, sir.
You check the second value. See, this is heat at node 5. That is Q5. Q5 minus 14406. Minus 14406. Is it okay?
Yes.
Yes.
Is it okay or not? See, if you
Yes,
take
sir.
the summation of this, it will tends to 0. That means it is condition of equilibrium. Yes or no? Yes or no? What is the addition of this one? Q1 plus Q5. Check it here. Q1 plus addition of all these. What is it? It is 0. Nah? So your answers are right. Clear? Yes or no? All of you, let me know.
Yes, sir. Clear.
Okay. Now see, if you need to see the animation, you have to go to plot control, go to animate, and deform results, right? So we are initially getting for temperature, right? We should understand how the temperature is varying with animation, right? So DOF with temperature. So I'll say okay. Okay, you can see this one. Can you see it? See, if you minimize the delay, okay, you can see the animation fast. Getting or not? See what I've done. I have minimized this value of delay. If I keep this delay in the center, okay, you can see a moderate animation. Yes or no? Getting or not? If you
Getting it.
increase the delay, your animation becomes slower. Your animation becomes slower, right? If you decrease the delay, your animation becomes fast, right? Yes or no?
Yes, sir.
Okay. So when you need to close it, directly don't close it. Initially you stop it, right? You stop it and then you close it, right? Similarly, you can get the animation. Okay, similar animation you can get it When you go to plot control, animate, deform results, you can also see the flux, heat flux, animation for the heat flux. Obviously, heat flux you have in X direction, right? So I'll say okay, okay. You can see this one. You can see the animation. See, this is the animation for heat flow. Last animation, it was for temperature. Okay. Are you able to get this one or not? Let me know. Okay. So we'll stop it and close it. Understood all of you the same?
Yes, sir.
Everybody understood this one?
Yes, sir.
Is it been clear to everyone? Is it been clear to everyone? Let me know.
Yes, sir. Clear.
Okay.
Yes.
Okay.
Yes,
So
sir.
today we will stop here. Okay. Just wait.